what we have done last Friday, okay, it's about a week time already. So what we have done last Friday is talk about how to sketch for tangent equations. We make the angle become pi on 2 and negative pi on 2 to solve for x. Those two x will be the vertical asymptotes. And then because you know the distance between the two asymptotes already, you can sketch all the other asymptotes within the domain. And then you have a mean line, kind of a mean line, which is the C value. So the stationary point of inflection will exist on that line, but in the middle of the two asymptotes. Also, whether it's increasing function or decreasing function depends on two values. One is the A value, the other one is the N value. If they're both positive or both negative, we have increasing functions. But if one is positive, the other one is negative, then we have decreasing functions. So similar to the one we have here. So after we learn how to sketch for it, same as sine, cosine, we'll learn how to solve for it. So how do we solve for tangent? It's very, very, very similar to sine and cosine, but much easier because we only have one solution instead of two solutions. You know, sine and cosine, in each period you have two solutions, right? Except you have 1 or -1, the extreme values. But for tangent, if you look at the graph, just sketch any horizontal line. For example, I sketch any horizontal line here. I'm trying to solve the tangent equals to that. And you can see in each period, there's only one solution, right? What's one period? In between the two asymptotes. In between the two asymptotes, you only intersect the horizontal line and the graph once. So we only have one solution as a general solution, like to use as a general solution. So that's much easier compared to a sine and cosine. So what we will do for the first one, we still just make tan to x to be on the left hand side, and then that's a √3/3. All right, can you tell me tangent what equals to √3/3? Pi on 6, 3, 4, 6. Okay, tangent pi on 6 gives you 1/√3. That's a √3/3. Okay, 1/√3, and that's a √3/3. So that's pi on 6 will give you that. So I just need one value. I don't need two values. So I already got the one I want. So 2x is just pi on 6. And then we solve for x. X is pi on 3. Next question is, what is my period? Wait. That's not right. That's pi on 12. I times a half instead of divide by half. Times a half. So pi on 12. What's the period? Pi on 2. Pi over n. N is the 2, so it's pi on 2. So period is pi on 2. So now I know one solution and I know the period. So similar, general solution. General solution is x equals to pi on 12 plus period times k, where k belongs to z. Okay, where k belongs to z. I can make that into a common denominator. Pi plus 6 pi k over 12, where k belongs to z as well. Okay, just make the same denominator. So what I want is domain is negative pi to pi, negative pi to pi. So I make k equals to 0. X equals to pi on 12. That's good enough. K equals to 1. X will be 7 pi over 12. Is that works or not? 7 pi on 12. Is that right? Yes? So I try k equals to 2. 13 pi over 12. Is that works or not? No. Okay, so we stop here. And go negative. k equals to -1, x is -5 pi over 12. That's fine. K equals to -2, x will be -11 pi over 12. 1 minus 12, so -11 pi over 12. Is that fine or not? That's fine. So I try another one. K equals to -3, x equals to -18, -17 pi over 12. Does that work or not? No. Okay, so the top we stop here.
Could you see, so like we go up to k -2, so it's -11 pi over 12. So it's pretty obvious.
Yeah, like that's fine. Like
We don't have
yeah,
to
you don't have to try the next one. So I just make it clear so it's not working, so we stop here. Just make sure we're not making any mistake. But that's fine if you're not trying the next one. But say if you have a really small period, that might work. Okay, so the solution. So our answer is x equals to -11 pi over 12, -5 pi over 12, pi over 12, and 7 pi over 12. Okay, let's see the next one. Well, next one is the -1. So positive one is really easy. Tangent would give you that value, and then the bracket is just that value. Let's think about the negative. The negative is, this is tangent a half x equals to -1. Okay, so -√2 divided by √2 is -1. Okay, tell me tangent what gives you 1? Pi on 4, good. Pi on 4 gives you 1. Okay, which quadrant is negative for tangent? Second and fourth. Second is the sine, fourth is the cos. Those two will be negative. But because I only need one value, I don't need two values. I just need one. So I can just ignore the bottom two. And I choose, well, you can use the bottom quadrant as well. So it doesn't matter which way you use, S or C, doesn't matter. But you just pick one. Okay, you don't use two of them, you use one of that. I choose the sine quadrant to do. So I need a reference angle of pi on 4. So the actual angle here is 3 pi on 4. Okay, the actual angle is 3 pi on 4. 3 pi on 4 will give you -1. Okay, 3 pi on 4 will give you -1. Or you can use the cosine one. The cosine one can be a negative pi on 4. Okay, it can be a negative pi on 4. So it can be this angle here. And then I can say it's a negative pi on 4. That's fine as well. So it doesn't really matter which one you use. But you just pick one. So for example, I pick the 3 pi on 4. Okay, I pick this one. Just use one because you only have one answer in one period. Because you can see 3 pi on 4 and negative pi on 4, that's one period. That's plus pi you get. Minus pi on 4, add pi will give you 3 pi on 4. So you will reach the next one anyway when you add the period. So you just need one solution. So x is 3 pi over 2. Okay, x is 3 pi over 2. What's period? So it's pi over a half, right? And that's 2 pi. So general solution will be x equals to 3 pi over 2 plus 2 pi times k, where k belongs to z. Let's have a look at the domain. The domain is 0 to 4 pi, right? It's most likely there's only one solution. 0 to 4 pi is one period, right? For this tangent graph, 0 to 4 pi is one period. In one period, how many solutions you might have? You will have for 10. One. You just have one. Sorry, 2 period. Then you should have like 2. Yeah, the 2 pi is the period. So 4 pi is 2 period. So I will have 2 solutions. Most likely to have 2 solutions here. So, okay, I will just make a common denominator for that again. So 3 pi plus 4 pi k over 2, where k belongs to z. That's easy for my calculation. So k equals to 0, x equals to 3 pi over 2. That's the first answer. K equals to 1, x equals to 7 pi over 2. That's 3.5 pi, still within the domain. But k equals to 2, x equals to 11 pi over 2. Is that still within the domain? No. Okay, not that one. Go for negative. K equals to -1, x equals to negative pi over 2. Well, can't have negative, that's not working. So x is 3 pi over 2 and 7 pi over 2. Okay, go back to find x-intercepts for example 2. So it's the graph we sketched Friday. So this one, yeah, there are here we have x-intercepts here, here, here. We have x-intercepts. So 3 x-intercepts. We want to solve for the 3 x-intercept. So the equation is -3 tangent not negative pi over 2x minus 3. Okay, so that's the equation, and I want to solve for x-intercept. We make that equals to 0. Okay, we make that equals to 0. Tangent pi over 2x equals to -1. That's -1. Well, because we already find what tangent what equals to -1, you know, like we use this angle here. So that's the 3 pi over 2 we just did last question. So pi over 2x equals to 3 pi over 4. Okay, 3 pi over 4. That's the -1 value. Okay, that's the -1 value. We can times 2 on both sides first. We get pi x equals to 3 pi over 2. And we can divide pi on both sides. We have 3 pi over 2. What's the period for this question? Just 2, because you can see the distance between 2 asymptotes. Just that's -3, -1, that's a 2. So period equals to 2, which is pi divided by pi over 2, and that gives you 2. Pi over n, pi divided by n is pi over 2. So we have 2. Period is 2. So general solution is x equals to 3 over 2 plus 2 times k, where k belongs to z. So x equals to 3 plus 4k over 2, where k belongs to z. Common denominator, 4k over 2 is 2k. So 3 plus 4k over 2, that's the general solution. Remember your domain is -3 to 2. Okay, domain is -3 to 2. So k equals to 0, x equals to 3 over 2. That's 1.5 already. If you try the next one, k equals to 1, x is 7 over 2. Doesn't work, definitely doesn't work. If k is -1, x is -1/2, that one's fine. K k equals to -2. X is -5/2. Okay, 3 minus 8, -5/2. So minus 2.5, that's still alright. So k equals to -3. X is minus 3 minus 12 minus 9/2. That's minus 4.5 already. That one doesn't work. So I should have 3 x-intercept. Minus 2.5, minus 0.5, and 1.5.
I understand like all the work you have or something, but I don't understand how finding tan links to finding these.
Which one? Which one?
Because we're solving the tan solution.
Yeah, we're solving it.
And these solutions are the x's.
Yeah, we y equals to this, and we make y equals to 0. So for x-intercept.
So why is it tan? Why is it not?
Oh no, because the graph is 10. We're sketching for the graph.
Okay, yeah.
The graph is 10. And that's why we're sketching for this graph and make this graph equals to 0. We solve for x-intercept.
So you can do the same thing with sine?
Yeah, we did that before. We did for cosine once. Okay. We have this coordinates here. Minus a half 0 here. And 3/2 here. Do we have that? Okay, that's why last week I said my graph is not really approaching to the asymptotes because the scale is not very correct. I need to make sure all my x-intercept is at the correct place. So it is at the correct place now. All right. Let's do the last page. Okay, first of all, what I want you to do is to sketch this graph within the period 0 to 24, okay? Give you 5 minutes to finish that graph. Okay, the sine graph is an easy sine graph, okay? It's a very easy sine graph. 5 minutes, sketch for the sine graph. Okay, to sketch this is a sine graph. First thing is we need 3 lines. Okay, the midline is 0. The max line is 4 and the minimum line is -4. So we have points moving on the 3 lines. Okay, we find a starting point. We make the angle equals to pi on 2. Okay, we make the angle become pi on 2. Doesn't matter if it's a sine graph, we just make the angle become pi on 2. We can always find out the maximum point. So the t equals to 3 if you solve for that. Okay, if t equals to 3, also your a value is +4, not -4. Therefore, we have 3, 4 as my maximum point. So this point is 3, 4. Okay, so we have a starting point already. Then I want to look at what's the period. Period equals to 2 pi divided by pi on 6. Okay, sine and cosine is 2 pi over n, not pi over n. Tangent is pi over n. So we have 12 here. So each step, it takes you 12 over 4 equals to 3. It takes that much to happen. So the next point here will be 0, 0. Okay, so this is my starting point, like the end point. Then the next point will be here, 6, 0. Yes? What do you mean by that? Why you start from 0? Yeah, do you remember I said we need a starting point with maximum or minimum? I don't want the point start from mean. Because for me, I don't know where, like whether next step should go up or go down. Like I don't know that. But maximum point, I definitely know it's going down and then further down and go up and then up. So I can control the pattern. But a midpoint, like middle one, I can't really see what's happening after that. We have 9. This is a 9, -4, and the next one will be 12, 0, then 15, 4 plus another 3 is 18. 18 plus 3 is 21. Get the minimum. 21 plus 3 is 24. We reach the end point of the domain. So that's all the point I have on the graph. Is exactly 2 period. Okay, it's exactly 2 period. It is start from 0, 0. So like in the end, you work out this start from 0, 0, and then going up first and then down, and then further down.
Is that not starting point?
No, 0, 0. No, domain. Like you look at your domain, you need to go like this is a starting point. Like where to start our graph, but endpoints. I'm talking about 0 and 24 is the endpoints. Okay, you should have a graph looks like this. And your graph needs to be beautiful enough to get the mark. It can't be too fat. Okay, it can't be. Well, that graph is not a sine graph. You will lose mark, like 1, maybe, shape mark. Okay, next question. Okay, next question is when. Have a look how it asks you when. When is not ask you after how many hours. When is gonna ask you what is the time, what is the date, or if like when is you need to answer the time is 12 p.m., 12 a.m., 3 p.m., 3 a.m. Like you need to answer the time, not how many hours, not t equals to what. So you need to give the exact time of the day. So time is the hours after midnight. So 12 a.m. after 12 a.m. So you can see the high tide is 3 hours and 15 hours after midnight. So I will answer as 3 a.m. and 3 p.m. Okay, that's how I will answer that. So you can use the graph to see when is the high tide and you answer the time. Okay, 3 a.m. and 3 p.m. What was the height of the high tide? 4 meters. Okay, so 4 meters. So it's the maximum value, which is 4 meters. Is that unit in meters? Well, I don't know what's the, well, if not given unit, so just answer 4. Okay, just answer 4. Is that meters? Given somewhere? Oh, yeah, it's at the beginning, so it's 4 meters. It's given. What was the height of the tide at 8 a.m.? So at 8 a.m. is when t equals to 8. Okay, 8 a.m. is when t equals to 8. So we want H8. H8. Okay, quickly go through the knowledge we learned before. Define functions is important for your test. Okay, define the function is important for the test. So, well, this one I don't really need calculator to do, but I want to show you how to define the function again on the calculator. So this function is called HT function with 4 times sine pi over 6 times t, right? Well, I can use, well, I want to change everything to x. I just change it to x. So this is my function. The name is HT. The name is HT. So I will press Control VAR. Got this arrow here. Control VAR. See the 9 button 9 above that is the VAR. So Control and then VAR. to have this arrow here and give the name. Because my variable has changed to x, so I will go for h bracket x and press enter. Well, I'll just do a couple of times. Make sure you can see that. So hx. It depends on what is your variable. Okay, if your variable is x, you put hx. If your variable you times t at the beginning, you put ht. So what I want now, I want t equals to 8, right? X equals to 8. So what I need to do is h bracket 8. Yes. Cas and 1-page double-sided notes. A4 double-sided notes. See, I can directly get values. Well, in this question, I don't really need to do this because it's designed as a hand approach question. But if give you, for example, age 13 or age 5/2, something like that, it's easy to just do calculator h bracket 5/2 and press enter. You can see the y value. You don't need to type the function again and again and again for different t values. Okay. Also, if you want to solve for the x-intercept, well, I know what's my x-intercept. My x-intercept is 6, 12, 18, and 24. I know what is my x-intercept. But say if I want to solve for the x-intercept, after I define the function, I can go menu 3, 1. Okay, very important thing. Very, very important thing. Tell your friends if they're not here. I also solve for circular function, right? Circular function got infinitely many solutions if no domain is given. So I can have infinitely many solutions. So I must restrict the domain when I solve for circular function. Otherwise, I can't solve out anything. So what I want to solve is the x-intercept in this question. So I will put h bracket x, h bracket x equals to 0, comma x. Okay, I will type this. Can you see? If you can't see, come to the front. See that? Comma x. Okay, the function equals to 0. So 4 sine pi on 6t equals to 0. Now I will go outside the bracket. Outside the bracket. Then go control equal to have this vertical bar here. Okay, this vertical bar here. To restrict my domain. What my domain must be is in between 0 to 24. In between 0 to 24. So 0 and control equal. Give this less than equals to, and then x. Control equal again, less than equals to 24. Okay, the domain must be restricted outside the bracket. Okay, outside the bracket. Use the bar and then the inequality to restrict your domain. And press enter. You can see 0 to 6. 12, 18, 24. So that's the 5 x-intercept we have on this graph. It's not something I need to use CAS to solve for this one, but I just show you how to use CAS to do it. And similarly, for your pre-test, you will have the similar thing to do as well. Also remember, restrict the domain, restrict the domain. Sine, cosine, tangent. If you don't restrict the domain, they will give you general solution only, which you don't understand what the calculator is talking about. So restrict your domain. Make sure you tell your friends, okay, anyone beside you today, you need to pass the information to them. You can tell them, watch the video for, what minute is that? About 25 minutes, 25, 28 minutes. Watch that part. Okay, so my h8, well, I know that's negative 2 root 3 already. We have worked out h8 is negative 2 root 3. But I want to solve that by hand. So how to solve that by hand is 4 sine pi over 6 times 8. Okay, it's 4 sine pi over 6 times 8. And that equals to 4 sine 4 pi over 3. So 4 pi over 3. So where's 4 pi over 3? Which quadrant is 4 pi over 3? Third. Pi plus pi over 3. So the angle's here. Whose quadrant is this one? T. Okay, tangent. Reference angle is what? Reference angle? Not pi in pi. Pi on 3. So negative, right? Sine is negative. So we have negative 4 sine pi over 3. Negative 4 sine pi over 3. Okay, what's sine pi over 3? What's sine pi over 3? Root 3 over 2. So negative 4 times root 3 over 2 gives you negative 2 root 3 meters. Okay, so at 8 a.m. we have that. Well, if you treat the ground as 0, it can go below the horizontal, like that's called the negative. It's not really the negative height. It's just for a fixed point, we compare to that point, and then below that is negative height. Okay, last question. A boat can only cross harbor bar when the tide is at least 1 meter above the mean sea level. Okay, see the mean sea level is the 0. When could the boat cross the harbor? When? Asking about when is talk about the time. Cross the harbor bar on 1st of January. Let's draw 1 meter above sea level first. Okay, 1 meter. Okay, here is 1 meter. Okay, this line is 1 meter. Above 1 meter, 1 meter above, I can go across the harbor bar. So, in between this time and this time, or in between this time and this time, right? That's in between those two periods. Okay, above. So I want to work out T1, T2, T3, and T4. Okay, so in between T1 and T2 and in between T3 and T4, that's the time I can go across the harbor bar. Any questions? No? Okay, now I want to solve for 1 meter. Okay, solve for 1 meter. What I need is HT equals to 1 meter. So which is 4 sine pi on 6t equals to 1 meter. Well, if you rearrange it, make sine pi 6t equals to a quarter. A quarter is not a special value for sine. I can't solve it by hand. I need calculator to do that. So calculator, I just copy whatever I have here and make the value become 1. Okay, I won't change anything else. Just height equals to 1, exactly equals to 1 for those 4 times. Press enter. Okay, I'll just do is exact value. I don't want exact value. I will go control enter to have approximation values. Just do a couple of that. Control enter, control enter. Okay, show you the, I can make you can see it. If you go here, you can see I have 4 values. Can you see that? I have 4 values. I'm talking about the time. Let's look at the first one. Let's look at the first one. The first one is when t is 0.48258, like this many hours after the midnight, right? But that's not 1 hour even. I also see how many minutes are there, like how many minutes after midnight. So I will copy this part of the answer. What you can do, you can go control, shift, hold shift and then left to highlight that part. Okay, so go shift and then left or right to highlight the part you need. And then you press enter. I'll go times that by 60. You have 28.9. Okay, 28.9. So let's say 29 minutes. 29 minutes. So T1 is 00.29 a.m. About 29 minutes. That's the time I can go across the harbor. Start, I can go across the harbor. Next one, next value is this one. 5.517416. Okay, I copy that value down. I will minus that value by 5 because it's 5 hours after. And also see how many minutes. Okay, the decimal, how many minutes are there. So times that by 60. I got 31.04, so 31 minutes. Okay, 31 minutes. So 5 hours and 31 minutes after the midnight. I will say go 5:31 a.m. T1 and T2. Can you see the line I draw? Because you have 4 different values. It's in between 2 times, in between the other 2 times.
Oh, you minus 5.
You need to minus 5 first. That's exactly 5 hours.
Yeah.
And you want to see the rest of the decimals. That's how many minutes.
So then that would be 5.
So 5 hours would be at T2, yeah?
5 hours, 31 minutes will be your T2.
Yeah. So you can minus.
Okay, next one. If you go up, okay, see the next value. Shh. Look at the next value. Next value is this one. Is 12 hours, 0.4825. If you can see the decimal, it's the same decimal as this one. Can you see that? Except the 12 hours is exactly the same decimal as that one. Because it's symmetrical. Shh. Because sine graph is symmetrical. So you will have the same time, same minutes. Therefore, the T3 is 12:29 p.m. Then if you see the next one is 17.5 or something, exactly the same decimal as this one here. So it's 5:31 p.m. here. Okay, it's 5:31 p.m. It's not, you see the values. It's 17 hours, which is 5 p.m. You see the values, like it's not adding period. You see the value, you can see the value. It is actually 1 period. It is actually 1 period. Okay, so we have, okay, last minute, just let me finish. We have in between those 2 periods of time, you can go across the harbor bar. Okay, and you can see they are like, you have, because we have 2 periods, so 1 period I can go across, the other period we have about the same time I can go across the harbor bar. So all the skills we have talked about in this question, you will need that for your test. Okay, define functions, solve for circular functions, substitute values, sketching for graphs, that's all the skills you have. And one last thing I want to talk about is how to sketch circular functions on that. For example, I want to sketch the same thing. 4 times sine pi t. Okay, we have pi over 6 times t, right? We don't times t, we can't times t here. We must times x. If we times t, that's, you can't have anything. Okay, so you must use x as your variable when you sketch for things. And remember to restrict domain. Anything deal with circular function, you need to restrict the domain. If you don't restrict the domain, it will be infinite many things. So we want 0 to, remember that's x, and 24. Okay, 0 to 24. Press enter. You can see part of the graph. And you can go menu 4 and 1 to window adjust that. Because I want only values in between 0 to 24, so I put -1 to 25. -5 to 5 will be a good Y value. And press OK. You have the complete graph here. Menu 4.1, window setting. You adjust the XY value, what you want to see. You only want to see in between 0 to 24. So I set it as -1 to 25 and a little bit space on top and bottom. 4.1. Menu 4.1. The first one, window. Well, depends on what the question you want to see, like how high is the graph and where you can see that, the max and the minimum. Okay, so that's all the things you need to know for your test. Okay, any more questions? If not, I'll stop that.